Hey everyone, day 12, so final day of Adventive Code 2025. It's kind of bittersweet. I'm so used to this only being the midpoint that kind of sad to see it ending already. But at the same time, it is kind of nice. I usually like head back home around like the 20th or so, maybe a little bit later. So there's always a few days where it's like really annoying because I'm like doing this at my parents' place or sometimes like at an airport, depending on the flight times. It's a bit of a pain. So it is nice that it's actually ending early in that sense, but I do wish there were a few more problems. But it is what it is. I don't actually know if this year will be the same as previous years, where the final part of the final problem is a star check. Basically, like if you have done everything prior, automatically pass. I actually already have it pre-coded, so that is the case. But if it isn't, I will just delete that line, I guess. I don't know. I'm kind of imagining, I guess we'll make this my guess. I've been very inconsistent with making guesses, but my guess today will be that it's relatively easy. Um, I feel like Topaz doesn't like to end on an incredibly hard day. Obviously, maybe that's different given a new schedule and everything. But I feel like he always likes to end a bit lighter in theme, just to make it a bit nicer for people. Then again, that's in large part I think because it is Christmas, so he wants people to probably spend time with family on Christmas rather than on their computers typing a coding solution, and that's not really a problem here. But we'll see. I still expect it to be a bit easier. I mean, probably harder than like day one, but like days 9 and 10 were pretty rough. I still don't have a working day 10 Java solution. Actually, it's on my bucket list. I ended up using Python to do it, but we shall see. A lot of questions. It is also cool though. I feel like this map is looking pretty decent because there's like 2 rows for each day, so you end up with like 24 rows, which gives the same vibes as the other one. Okay. Oh boy, this is quite the interesting looking input, huh? Let's see. All the presents come in very weird shapes. Okay. Contain a list of shapes, yeah. Contains the size of each region and a list of the number of presents of each shape that need to be in that region. Okay. Shapes can be rotated and flipped, can't overlap, can fit together. How many of the regions can fit? Oh my goodness, that sounds incredibly difficult. Wait, what? Huh. Are the shapes in the example the same? Let me see. No, they're not. Okay. Good to know. Although they're quite similar. Yeah. Okay. I mean, there's obviously some trivial heuristics here. But nothing more than that immediately jumps out. Like obviously, the first heuristic. Each one we can upper bound it and lower bound its need, right? So let's actually start there. I'm curious how many there. So there's what, 6 possible shapes? Okay. How do I even parse this? So we have while in the next line. Let's just do these 4 at once. So it would be list shape. Shapes equals new array list. And then we have like class shape, which is, I think we just always assume it's 3 by 3. Because I think they all are. Yep. Cool. And then basically we'll do public shape right. But in the meantime, sorry, I'm just thinking how I can do a very basic check. I'm curious how many lie in this sort of sweet spot, right? Theoretically, if we reserve 9 squares for each shape, we're guaranteed it'd fit. And if we reserve, 7 squares for shape 7, or for 0, for example, then it will, almost certainly not fit. Because it'd mean that everything has to be like perfect. What the heck? Why did it do Java AWT? That was very strange. I'm not sure why I imported the wrong thing, but it is what it is. So we do in dot next line, we don't really care about the first thing. And then we do shapes dot add new shape in dot next line, in dot next line, in dot next line. Cool. Okay, so now we've gotten rid of these, and now we just do in dot next line one more time. Oh my god, I keep typing int dot next line. Why do I keep doing that? Alright. So now we have a line. Right, so if we split on space, let's do I really want to do the naive one just to see how it looks. And obviously it won't work, but I'm just curious, I'm not planning on getting a very fast time here, so we don't have to worry about that. We can do, I guess, how do I even do this? So I don't know why I'm struggling so much on this. So we have string size equals line 0 dot substring line 0 dot length minus 1. Get rid of that colon. Actually, maybe we just split on colon, right? And then numbers is line sub 1 dot split on space. Cool. And you know what? Let's just list integer hard code, new array list. Then we do hard code dot add. We just need to add 6 values. It's 7, 7, 7, 7. Okay. 1, 2, 3, 4. So 5, 6, 7, 7, 7, 7, 5, 6. 7, 7, 7, 7, 5, 6. Cool. So we can do int naive upper equals 0, int naive lower equals 0. Actually, let's make this an int. Inner.parse int line sub 0 dot split on times sub 0 times, and the same thing but 1. I don't know why I say sub, by the way. It's like at. Okay. So then we do int impossible equals 0, int possible equals 0, int inconclusive equals 0. Okay. So then we have for string s in nums, int num equals integer dot parse int s, and then naive upper plus equals num times 9, naive lower plus equals, I guess we can't do this. We have to do it as a for loop, or like an index-based for loop. Hard code num times hard code dot get. Cool. So now we do if naive upper less than size. Oh, 9 is not necessarily enough, depending on the shape, huh? Oof. Okay. So let's actually do length and then width. So we do if naive upper, let's just go to this, because it's just a number of elements, right? Is less than length divided by 3 times width divided by 3. Then possible plus plus. If naive lower is greater than length times width, impossible plus plus. Else inconclusive plus plus. And then we do system out dot println possible plus impossible plus inconclusive. Dang. What? Now parse int num sub I. Oh, is there a space at the beginning? There is. Okay. I guess we start at 1. Do -1. Oh, most of the shapes are not inconclusive, actually. They're either possible or impossible. Okay, that's interesting. I'm curious if that's true for this. It's hard to say for this set. Okay, well we know we have a bound now, right? It's clearly between 386 and 452. Now, how do we narrow that further? Actually, what if we just print those out? Naive lower plus length plus width plus naive upper. How do I, let's do times 9. Like, how tight are the bounds? Wow, these bounds are horrendously not tight, huh? 1728. Actually, let's do this instead. Like, how close is it to each bound? Oh, so it's like right on. Wait, can I do equals? What about that? Oh, wait, no way the naive solution just works, right? Holy moly, it does. Wow, I did not expect the naive solution to work. I actually am top 100. What the? Really? Okay. I thought for sure there would be some trickier cases, but that is very nice. I mean, the bounds definitely make sense, right? Like, if you can give a 3x3 region to every shape, then you're guaranteed a working solution. And similarly, if you have fundamentally less squares available than the squares of the shapes, it's too much. But like, surely, like, you can fit some of these shapes a little tighter together. Although it's not actually immediately coming to mind how. Oh yeah, like this one. You could fit 2 of these in a 3x4. I guess it just didn't matter. Okay, well, nice, easy day 12. I would say see you guys tomorrow, but there's no more problem. So I guess see you guys next year, unless something happens this year. Maybe he does a bonus question on Christmas or something. If that happens, I'll be here, but I think it's unlikely. See you.